Hi, I'm Jane from Amazon Web Services. Today I'm going to walk you through how to use AWS Glue to manage the metadata associated with your data on AWS. AWS Glue is a serverless, fully managed, and cloud-optimized extract, transform, and load, or ETL service. It provides automatic schema inference for your semi-structured and structured data sets. Glue will help you understand your data, suggest transformations, and generate ETL scripts for you so you spend less time hand coding. Glue will also run your ETL jobs, automatically provisioning and scaling the resources needed to complete them. I'm going to focus on how Glue automatically identifies data formats and schemas, and then builds a metadata repository, thereby eliminating the need to manually define and maintain schemas. Let's look at an example. Assume that I'm a data scientist for an airline, and I've been asked to analyze flight data to determine the popularity of various airports. I have files stored in Amazon S3 containing flight data for the year 2016. The flights are partitioned by month to help organize the data and make it easy and fast to access. The data is stored in CSV format and is organized according to fields such as year, flight date, airline ID, and flight number. Let's see how Glue can automatically infer the data format, schema, and partitions of this data and create a corresponding table entry in the Glue data catalog. The data catalog is a metadata repository that can also serve as a drop-in replacement for Hive Metastore. Crawlers are programs that run through your data and infer their schemas and partitions. Let's get started by logging into the AWS Management Console and navigate to Glue. First, I'm going to create a crawler for my flight data. I'll name the crawler Flights crawler. I'll pick the IAM role for the crawler. This role provides the crawler with permissions to access the data store. Crawlers can infer the schemas of several popular data formats, including JSON, Parquet, CSV, and those of relational stores. If I have a custom file format that Glue doesn't recognize by default, I can create a classifier with a grok expression and associate it with the crawler. Right now I'm dealing with the CSV data that Glue recognizes, so I'm not going to add a custom classifier. Next, I'm going to specify the Amazon S3 path where my data is located. I can use the S3 picker for this, or just paste the path. If my data exists across multiple sources, for example S3, Amazon RDS, and Amazon Redshift, I could add additional data stores to the crawler. For now, let me stick with S3. I can choose to run this crawler on demand or on schedule. Automatically scheduling a crawler helps me identify any changes to the data and keeps the data catalog up to date, which is especially helpful for change data management. I'll run it on demand for now. I want my inferred tables to be created in Flights DB database, which I will create now. A database is a container of tables in the data catalog. I'm going to specify a prefix, Flights, so all the tables created by the crawler contain this prefix for easy identification. I'd like to call out one important feature here. Crawlers can handle changes to the schemas. This ensures my metadata is always in sync with the underlying data. The default settings allow my crawlers to modify my catalog schemas if the underlying data is updated or deleted. I could choose to set my crawler to ignore these schema changes instead. Let's review the crawler specifications and create the crawler. The crawler has been created. Let's run it. The crawler is now running. Its status is starting. 13 seconds have elapsed. The crawler has completed running, and it created one table in the data catalog. The table is a metadata representation of data and points to the location where the data is physically located. Let's find that table and take a look at its schema. The inferred schema matches the schema of the data we saw in the CSV file. I can edit the schema. Let me change the data type of column year from big int to int. I'm saving this to create a new version of the table. I can also compare schemas between two different versions. Here I can see the change that I made to the data type. I can also view the partitions associated with the table and the properties of those partitions. Now that my table is defined in Catalog, I can query it using Amazon Athena or Amazon Redshift Spectrum. Both products allow you to query data in S3. We've seen how Glue makes it easy to crawl data and maintain metadata information in the data catalog. However, there are other ways to populate your catalog with tables. You can manually define the table, import from an external Hive metastore, or you can run Hive data definition language queries. To learn more, please visit aws.amazon.com/glue. Thanks for watching.